Hello all. Today we are going to see how to find out the resultant of parallel force system. Now in parallel force system, first you have to think about how the axes are going. You can have a short figure like this to know how the axes are going because generally in asking the problems, the axis position will get changed every time. So here in this problem, we have x-axis in this direction, y in this direction, and z in this direction. Now observe the forces which are there in the force system. So as you know, this is the parallel force system. The forces will be parallel to any one of these axes, means either x-axis, either y-axis, or either z-axis. So here in this case, we are having all the forces which are parallel to z-axis. So if you see here, if all the forces are parallel to one axis only, your resultant in general will be the combination of this x component, then y component, and this z component. But now in this case, as all are in one axis, we can say that r is equal to what? Directly rz means what? Summation fz. So if you calculate that r is equal to everything in minus because it is going downward. This is plus z, this is plus x, this is plus y. Beyond this, there will be minus z, here minus x, and here minus y. Are you getting? So what is r is equal to now? Summation fz rather here. So what is fz? That is all the forces and their addition. So starting with a point, that is 400 Newton force. It is going downward, that is why minus, then again minus 500 at the origin, again minus 600 at the origin, at the C point, and minus 100 at the B point. So R is coming as around about minus 1600 Newton. Yes, it is. So that is R is equal to what? R is coming as minus 1600 Newton, means R is 1600 Newton, and it is going downward. So finding out resultant is a simple job in case of parallel force system. Now we will see how to find out the position of resultant. Now to find out the position of resultant, we first of all how to see what is the particular position at which each force is there. And one trick or one point you have to always analyze, that we have to find out the position using Varignon's theorem. Varignon's theorem about, first of all, if you want to find out the x distance of resultant as we have shown here, we have to find out resultant about, or Varignon's theorem about y-axis. So always remember that how to particularly analyze that. Just we are taking the movement about y-axis. So if you have a stick like this, so keep this stick along the y-axis and just imagine that it is tied with this rope and a stone is particularly here. Now see here how this particular can help you. Now you have to use the Varignon's theorem about y-axis. So what is the Varignon's theorem? Summation of movement about all the forces about y-axis is equal to what? Movement of resultant about y-axis, isn't it? So summation of movement of all the forces about y-axis. How they are going? They are going like this, starting with 600 Newton force. So it is on y-axis itself. So it is here only. So we cannot have any movement. Same thing will happen with 500 Newton force. As it is on the y-axis, it will not create any movement about y-axis. Now which forces will create movement? 100 Newton and 400 Newton. What is the position of 100 Newton with respect to axis? It is 5 meter. So as it is 100 Newton force with respect to axis, we have to see the distances along x-axis. So along x-axis is what distance? 5 meter. So how it is creating the movement? It is going downward. So if we are just releasing the stone downward, how it is going? It is going clockwise. So it is positive 100 into 5. Are you getting? Similarly, about 400 Newton, how can we have the moment of this force about this axis? Now see, 400 Newton, how much distance away from that y-axis? Along x-axis, it is 5 plus 5, 10 meter. And it is again going like this downward. So it is creating a clockwise movement. So plus 400 into 10. Are you getting? Is there anything remained in this time? No. So what is this? R into the distance of r from along x-axis is always here we are taking a x, as it is also going downward, our assumption, or rather it is going downward, so it is minus. So we have to put that particular so not minus, here also plus. So that is 500 plus 4000 total divided by what is r we have with us, that is 1600 into x. So x will be now 4500 divided by 1600. So more correctly, the answer will be, I will be showing you, the more correct answer will be like this. Okay, sure. So the answer, what the answer is coming, let me know in comments. That will be in meter. Now similar thing we have to perform again about x axis. So how x is coming here? So it is coming, yes. Okay. So whatever the meter is there, we have to find out here. Next, we have to find out the distance y. So similar thing we have to do again about which axis? About x axis. So it is very important. And the similar thing we have to do again about which axis? X axis. Okay. So how we can particularly calculate? Now you can see one by one the same theory have to be applied like in other way, that we have to find out the stick, and that stick should be in the direction of your x-axis. So it should be revolved like this. So your stick will be now this, and so on this stick we have that tied rope here like this, and this is the particular stone we are having. Now see, along x-axis, how many forces are there on the x-axis? 500 Newton is on the x-axis, 400 Newton is on the x-axis, so they will not create any movement. Which forces will create the movement? 100 Newton and 600 Newton. How they will create the movement? 100 Newton is going downward. The axis, distance we have to particularly see is along y. So it is 6 meter and it is going downward. So it is going to create a anti-clockwise movement here. So minus 100 into that distance is 6. Similarly, 600 is 6 plus 2, 8 meter away from x-axis, and it is again creating an anti-clockwise movement like this. So it is minus 600 into distance is 8 meter. And resultant is having the same again direction, that is r is always again minus here because anti-clockwise movement into y. So what is the answer coming? That we have to write. What the answer is, that 600 minus 600 minus 4800 minus 1600 into y. So the distance will be y is equal to something in meter. So we can write that resultant R is equal to 1600 Newton. Therefore, is acting at this x, then this y, and then that is 0. So I'll be coming back again to show you what the particular answer of this, or otherwise you can comment me the answers into the boxes. Thank you so much.